My talk today is called Economic Incentives and the Network. And without further ado, I think let's get into it. So as Steve said, one of the most game-changing aspects of Bitcoin is the system of economic incentives that it creates that causes it to spontaneously form into a very robust and useful for everyone in the world to be able to depend on. And if I can get my presentation to work. So Bitcoin is a peer-to-peer cash system underpinned by a set of economic incentives. So for users, this means that Bitcoin really is a low-cost, very reliable public ledger, and it is built to facilitate all kinds of exchange, but also many kinds of novel computing systems, data storage, which all are done on top of a very versatile cache layer. And so it is that cache system that we use when we implement these other things that sit atop Bitcoin. So this cache system really is built on top of that system of economic incentives. And it is those economic incentives which are designed to really encourage the people who run the network for the users to compete in a way that is very cooperative and honest. And what you'll see as we go through the presentation, that there really is, or there really aren't any ways that you can compete in Bitcoin against someone who is being more open and honest than you without being severely disadvantaged. And this is something that I find very fascinating about the system. It also creates a network that's extremely scalable, very, very versatile, and really exists without any kind of centralized control. And we'll discuss a little bit the topic of the structure of the network, and that's something that will be covered more in depth by Owen later on in another one of the talks that we're having today. But really about how this feeds into the way the network accommodates a huge amount of demand. So when I say that the network is not centralized, or that there is no centralized sort of organization calling the shots, that does not mean that it is decentralized, in that it has to be spread out across sort of many systems all over the place. But think of it more as a distributed system where the consensus is distributed amongst the nodes who are participating in that cooperative competition to honestly operate the network. So miners are incentivized to participate and really to ensure their own long-term survival. So what you'll see is that nodes are incentivized to scale the network as a group. They do this in lockstep and in order to maximize their individual profit. And one of the things you'll also see is that it's very dangerous to really act outside of that group that operate at the core of the network. And it really all comes down, or comes back, I should say, to the white paper. And in section 5, there is outlined a set of steps to run the network. And as you see on the screen, new transactions are broadcast to all blocks, nodes collect transactions into a block. We'll go through these during the talk, but what I've really sort of discovered in looking at this in a lot of detail is that these aren't so much just steps to run the network, and that they are more a list of instructions to be the best possible participant in the network. And if you don't do the things that are listed here, so the reality is that anybody who tries to participate in the network can really act in any way that they like. And it's up to the rest of the consensus nodes to decide whether or not their participation is correct and honest and valid. And by following the steps that are outlined here, this is the best way to participate. And we'll go through why that is. So, but looking at the first step, so new transactions are broadcast to all nodes. So what that means is that when you generate a transaction in your wallet, and this might be a transaction that you then pass to a merchant or a process who then send it down to the network, that transaction is as quickly as possible sent out to every other node on the network. And there's a very good reason for doing this. And it really comes to the front when Bitcoin is scaled into a very large system handling millions of transactions per second. And that is the fact that when a node actually finds a block, it has to propagate that block and its full contents out to every other miner as quickly as possible, because any time spent trying to find a competitor to that block is opportunity lost at securing the reward that that block contains. And so a lot of people are under the impression that there is actually an economic incentive there for nodes to hoard transactions, to not broadcast them out to all other nodes. But when you look at it from the perspective of how a node needs to announce their own reward out to the rest of the network, it really makes no sense economically for them to do that. And so one of the things that you can see in the image on the left-hand side of the screen is what we call this small world network that forms at the core of the network. And that is a small world network really refers to a network where all of the, or almost all of the nodes are connected to almost all of the other nodes. And if you look closely, you'll see that some of the nodes in this graph are not connected to some of the other nodes, but that they are all within one hop of each other. And that is what we see happening at the core of the Bitcoin network. It's a very, very dense cluster of high capacity computing systems with very high bandwidth. And that is designed, or that is built to make those nodes the most competitive systems possible, and to ensure that the rewards they earn through actually taking care of the network for us have the best chance of actually being kept. And we'll go into that a little bit more. So step 2, each node collects new transactions into a block. Now, this is probably one of the most fundamental functions of the network, is the actual building of the blocks and the construction of those transactions and that public ledger that we all write to into the blockchain. And as nodes do this, they construct what's called a block template. And each time they construct a block template, they create a what's called a coin-based transaction. And that coin-based transaction holds all of the rewards that they are going to basically collect from building that block. And that includes any transaction fees, as well as the new coin distribution. And that new coin distribution is something that happens with every block over time and slowly reduces and will eventually peter out sometime next century. But in that coin-based transaction, the miner actually identifies themselves, and using some techniques we call miner ID, there's also a merchant API, they can advertise the cost at which they will put transactions into their next blocks, and allowing them to openly publish their value proposition to the users of the network in such a way that everybody can see it. And this is one of the mechanisms by which these competing enterprises are actually incentivized to push prices down to win more of that network traffic and really improve the experience for the users. So as the networks register more transactions coming in from the network, what happens is they actually extend the Merkle tree. And each time they create a new template, they do this in a way that is additive. So as that Merkle tree grows, they don't need to rebuild the whole thing every time. And this becomes very important at scale because as the blocks are built over a period of, on average, 10 minutes, but updated once every few seconds, once you're creating blocks that have tens or hundreds of millions of transactions in them, it would be cost prohibitive to have to recalculate that entire hash tree every couple of seconds. And a Merkle tree is quite a simple and efficient structure to build. And as you'll see, it kind of is very efficient for us to add more transactions. So the orange nodes that we have here are the nodes that have to change. The green ones are the ones that we're actually adding into the system. And each time we add more, we update that Coinbase transaction, we update those rewards. And so what happens then, as that grows bigger and bigger and we keep publishing new templates, the node then works on finding what we call proof of work. And so this is actually a hash of this block header that includes an immutable record of all of the transactions that are in that iteration of the Merkle tree. And it's important to understand that when we do say proof of work, there are really two parts to it. So there's the proof that you are able to, as a node participating in the network, to actually generate a large Merkle tree and handle the volume of transactions, but then also the ability to find a hash that solves the difficulty problem that you need to solve to actually win a block. And then it's the propagation of that is the next part. So as we hash, there are various techniques that we use to ensure that we have we can find that value. And basically what we're looking at here is that these are a very scalable data structure, and the incentive here is not to limit the size of the block, but to actually enable the node to capture as much of that utility value that's being broadcast into the network from users all around the world as possible. And so as the network grows, the incentive is for each node to be able to handle the full amount of traffic that is coming into the network. And really the competition is between the fastest, most capable nodes on the network. And any node who wants to participate has to be capable of gathering, processing, and storing every transaction that's happening on the network globally in real time. And that's one of the things that we're very laser focused on here in Bitcoin SV, is ensuring that the software that's used and the hardware that's used on the network is built with a necessary level of robustness to allow for the network to scale. And that allows the people who are building upon the network and who are using the network to actually push very hard on that system and really use it as much as possible, push many transactions of different types, large transactions, transactions that carry large amounts of data onto that network, and have it be handled in a manner that is reliable and cost effective, and at any time of the day, on any day of the week. And that's not something that you see in a lot of the blockchain networks that are around, but it's certainly something that we are very focused on at Bitcoin SV. So step 4, when a node finds a proof of work, it broadcasts the block to all nodes. Now, this is probably the most important, I guess, directive here, because this is where the node actually captures that value. So it's just spent a fair amount of computing power and energy building a block, solving the hash puzzle, so finding something that matches the difficulty, a hash that matches the difficulty. What it now has to do is announce that block to the rest of the network. And what happens if, so as soon as that node has found that valid puzzle solution, any energy that is spent by any other node trying to find a solution for the block that they have built upon is potential energy that is going to cause an orphan race for their block. Now, an orphan race happens when 2 nodes find competing solutions for the same block. So it's very important for a node to be able to spread the announcement of their block across the network as quickly as possible. Now, when we say across the network, what we really mean is across that consensus network that forms the small world at the core of the overall Bitcoin network. And so this is one of the primary drivers of that hyperdense connectivity that we see. And it's a very important way that nodes actually kind of lock in that money that they are awarding themselves through the Coinbase transaction. As soon or as quickly as they can spread that propagate that message around the network, the rest of the nodes on the network can start building upon their block. And once a node has found another block on top of theirs, their chance of being able to retain that reward grows. And as the blocks pile up on top, they have to get 100 blocks on top of their block before that reward can be claimed. So again, going back to step 1, a node must transmit all transactions to other nodes. What happens in this step, if a node has been hoarding transactions and then they find a valid block solution, at that moment, they don't just have to transmit the block solution out to the rest of the network. They also have to transmit all of those transactions that they've been hoarding, and then wait for all of the other nodes on the network to validate those transactions, then validate their block. And so all of that time that is happening, those nodes are going to be expending energy trying to find a solution that competes with their block announcement. So you can see that there's a very strong incentive for nodes to play this game in a manner that you could call open misère. And that basically means all cards face up on the table. These are the transactions I have. This is the order they're in, everything. So there's another myth that was used to be talked about quite a bit. It's called selfish mining. And I just wanted to take you through how that works and really show you that by not following this directive number 4 to broadcast the block to all nodes, you're really actually putting yourself behind the nodes who are being honest. So selfish mining is the premise that a miner could find a block solution and withhold it from the rest of the network and try to find an additional solution on top of that one, such that and operate in such a way that if another node found a different block solution, that they could propagate their previously found solution out before that one, and with less than half of the hash on the network, actually conduct almost like a 51% attack. But as you'll see, it's actually through this very dense connectivity that happens at the center of the network that this attack is foiled. If you see some of the maths that's gone into actually proving that this works, none of it really takes into account the fact that the nodes at the center of the network transmit messages between themselves almost instantaneously. But so the premise is that a selfish node would find a valid proof of work and only broadcast that to its own sub-network of other selfish nodes. Now, because this selfish node has a fair amount of hash power connected to it, by necessity, all of the other nodes will also be connected to it. So this will be a well-known node on the network. It's very likely that the enterprise that operates it would also be known to the other nodes on the network. Now, when another node finds a block, what then has to happen is that that node has to announce that to the selfish node, and the selfish node then tells all of its own network of other selfish nodes to broadcast the selfishly mined block. But before that can happen, the same node that announced its block to the selfish node has already announced it also to most of the rest of the network. So maybe the selfish node will catch one or two of the other nodes out and trick them into mining on top of their selfish block. But the reality is that the honest node is always going to come out in front. So when finding proof of work, it's always very important to ensure that you lock in the reward that comes with that as quickly as possible. And you do that by broadcasting that block to all nodes as quickly as possible. So the next step is the validation of the block. So nodes accept the block only if all of the transactions in it are valid and not already spent. So there's really actually two parts of this, to this. So the node must first get the block header. Now the block header contains the Merkle root of the Merkle tree. Now to be able to validate that Merkle root, the node must also have a full list of all of the transactions that are in that block and the order in which those transactions are in that block. Now, early on in the network, when the blocks aren't so big, it's okay to receive that transaction and transaction ordering information after the block announcement, because it's relatively fast to rebuild that Merkle tree and check that that Merkle root does form part of that block header that is announced across the network. However, what will happen as the network scales is that it will actually become extremely difficult to transmit all of that information that is that represents all of the transactions in that block to every other node, and do that quickly enough that they will be able to validate that block and stop spending money trying to compete with it. So what will actually happen, and it is happening, it is being worked on now, is that the nodes will begin transmitting the information about their block before they have found the valid solution. So each time they kind of lock in a block template with a Coinbase, and start doing proof of work on it, they will actually transmit to all of the other nodes in that central consensus network the order of all of the transactions in that block. And they do this so that as soon as they find that valid block solution and announce their block to the rest of the network, that those nodes don't have to spend time and energy building that Merkle tree to validate the block. They've already done that part of the work, and they can straight away accept that block and start mining on top of it rather than the previous block. So all of this is done to prevent nodes from expending energy competing with their block. And this goes a little bit further in that, so another thing that a node does not want to do is that they do not want, another thing that nodes want is to actually know about the blocks of all of the other nodes, such that as soon as one of them announces a new block solution, that they can prevent their own energy being spent on finding a solution to a block that might potentially end up in an orphan race. And so what will actually happen as well is that those each node will end up carrying the copies of all of the other Merkle trees of every other node in the network. And so we can see from this that it's going to be very important for nodes to be completely open and honest with each other to enable them to be the best possible competitors. And so what you see at the core of the network is not just an extremely robust and densely connected network, but a network that operates with the utmost in openness and honesty. And this is really something that we don't see in the internet today. We don't see in financial networks of today. Most things have to be done in secret. There's encryption, but in Bitcoin, everything is completely open. The blocks, the transactions are all unencrypted, plain text, and everything is published completely in public. And I'm very optimistic that having a layer at the center of the network that promotes such a level of openness and honesty will propagate similar behavior out to the users of the network. And so the final directive in that section 5 of the white paper is that nodes express their acceptance of the block by working on creating the next block in the chain using the hash of the accepted block as the previous block. And so really what we've said through this is that when we say proof of work, there's more to that than just hashing the block. There's work in being open. There's work in scaling the network. And it's a combination of all of those things that enable nodes to be the best possible competitors. And so these directives are really what is incentivizing this network to very, very spontaneously, in a completely leaderless manner, to form into this highly reliable, highly robust network. So, yeah, that's the talk. To summarize, really, it is these incentives that drive Bitcoin to scale. And it's very easy to see that long term, if there is no scale, if there aren't very, very large numbers of transactions being broadcast onto the network with ample fees to gather, that the network cannot survive. And there will come a point where the value in transaction fees being paid to miners eclipses what they currently receive as block rewards. And that will really be the moment where we can see that the network has achieved that long-term viability that we need. What we also can see is that honesty and openness is the best path to profit in Bitcoin. And there really is no way of competing in the network by being dishonest. And it's quite an interesting paradigm shift. And I'm sure that it's something that a lot of people are going to have to come to terms with. But I think also something that is going to improve outcomes for many people around the world. The other thing is that proof of work really is only partially related to that energy intensive activity of actually hashing to find that block, that valid block solution. And it has as much to do with that as it has to do with the construction of the block prior to actually doing that hashing, and in the communication of with the network, that broadcasting of the transactions, that constant updating of other nodes with what is being included in its block. And then, yes, that the network really does form in a completely spontaneous manner. And I really want to reiterate that, the network is open for anyone to participate. So anyone can go and attempt to build blocks on the network, but only somebody who can openly display that they have invested the money required to perform the proof of work is really able to participate. So the network sort of grows in density as the rewards grow in value. But one thing that can also happen is if those rewards disappear, the network can also deform in line with that disappearance. And so this is something where we see short-term incentives versus long-term incentives. And so in some places we've seen there's a short-term incentive to have a small number of transactions that pay very high fees. And that is one way to sort of bring money into the network and generate the creation of that density. But if those transaction fees aren't reliable, aren't happening every day, aren't constant, that network will never really become very robust. You need very large numbers of transactions happening all the time to ensure that constant influx of money and investment in the network. So that's the talk. I really hope you can take something away from that about why the network is built the way it is, and really what is happening at the core of the network in that consensus system that is going to allow you as the application builders who are leveraging this system to really be able to depend on this and to build applications that bring thousands, millions, billions of people into the network and use it without having to worry about its performance, about fees, about transaction confirmations, this kind of thing. It's your ability to move away from that and to focus on using the ledger as a ledger, and not really to think so much about the blockchain. So thank you very much. I hope you enjoyed that. Now, I do believe we have some time for Q&A.
We do have a few questions here, and I've highlighted the one that I find the most interesting. I think you actually touched on this subject. How can you make sure or prove that nodes behave honestly?
Well, it really is an incentive for them to do that. And I mean, there's nothing that they can publish in a block that really is not something that was created by a user. So when I send them a transaction, the only option they have is to put it in a block or to not put it in a block. There's nothing that they can actually do with my transaction that would really, that they can't take the money out of it or do anything like that. So, I mean, it's not so much proving that they're honest. If they're dishonest, they will just be uncompetitive with the other nodes on the network. And eventually, through that dishonesty, they will deplete their resources and no longer be able to participate in the network. So yeah, it very quickly becomes a very costly exercise to act dishonestly on the network. And if they are caught doing, because proof of work does require a very large investment in terms of resources and computing power and time and money, it's almost impossible for a node to actually be unknown in terms of the enterprise that is operating it. And as such, really, if they were to act dishonestly and to do something that was unlawful, it would be very easy to then prosecute them as well. So, I mean, I think it's there's not really a need to prove that nodes are honest. It's that there's nothing that they can really do that's, I guess, dishonest that can have any material impact on the users of the network. The only impact it has is on their profitability.
Yeah, and one could also argue that of that limited set of things that they can do dishonestly is essentially to produce an invalid block. And it's not so much that you need to prove that they're honest, it's that every single other miner on the network will know that that is an invalid block, and they have a very powerful incentive to punish that miner by orphaning the block.
Yes, that's right. I mean, if it's an invalid block, you just don't build upon it. And so all of the work that went into building that block, that dishonest block, is basically wasted money and that depletion of resources.
Exactly. So we've got a few more questions here, but we're a little time constrained. So I believe there's a mechanism for answering those questions later on. But for now, we are going to have a very short break, and we'll return in just a moment with Jab Wahab and a presentation on miner fee calculation and the merchant API, which is one of the first things we touch on directly in the Bitcoin community. So thank you.
Thank you very much.